questions on yesterday's assignment? So we are going to go ahead and get started with today's factoring using the Berry method. The Berry method is not how I typically taught factoring, but it's super simple. So it may be a new strategy for you as well, but I think you're going to find it really simplifies things a lot. The only thing with it is that you're just following steps. You don't really have to understand how it works, right? So remember what factoring is. All factoring is you take an expression and you rewrite it in a different form, right? So for instance, if we had the number 15 and we wanted to rewrite it in an equivalent form, we could say 15 or 3 times 5, right? 15 or 1 times 5. If I multiply those two numbers together, they give me my original expression. So that's what we're doing today. They're going to give us a quadratic expression, so a trinomial, and we are asked to factor it. So rewrite it in an equivalent form where if we multiply those factors together, it will equal or be equivalent to the expression we started with. So that's what factoring is. You guys have factored all your life, just never, even when you were little, when you first started multiplying and dividing, you learned the factors. Your multiplication tables you were factoring numbers. So this is what we talked about yesterday. Who wasn't here yesterday? Patience, Alana. Okay, so this is one of the tools we use as part of this Berry method. And we did go over this early in the year when we factored during the course of our geometry. But you're looking for the pattern here between the top number and the bottom number. Yeah, we did it yesterday, but I got a couple kids that weren't here yesterday, so I wanted to recap it real quick. This is the exact same thing that was on our notes yesterday. So do you see here, Alana and Patience, this number 10, if you multiply 2 and 5, you get 10. And if you add 2 and 5, you get 7. Alana, do you need to sit in this chair so you can see? Oh, you want to move up? All right, so this next one, Patience, do you see 6 here is a product, 2 times 3 is 6, 2 plus 3 is 5. Okay, and same with that last one. So we're going to do this one together. I know that you guys don't have this on your notes, but just as a little recap, what's going to go in the top and bottom spot of number 1? Say it again, Mason? Yes, so we're going to multiply these to get 18. We're going to add them together to get 9. What's going to go in the top and bottom here, Grace? Good. What's going to go in the top and bottom here, Amelia? Number 3. Yes, negative 7. All right, and 4 and 5 are in the form that we're going to be using this today. We are going to be able to find the product and the sum, and we're going to use those two to find these two numbers. So what two numbers, if I multiply them together, do I get 12, but if I add them together, I get 13. 12 and 1. Does not matter which order. 12 times 1 is 12. 12 plus 1 is 13. How about for number 4? What are the two numbers? Negative 6 and 4 does give me negative 24 when I multiply it, and does give me negative 2 when I add it. So that's one of a big part of this Berry method of factoring. All right, my guys that weren't here yesterday, you good with that? Alana, you're good? Patience, you're good? Okay. So we are going to start by factoring. This is a quadratic trinomial. Quadratic just means that the exponent of this 2 here, that's the highest, the degree of this expression is 2 because the highest exponent on the variable is 2. So 2 is a quadratic. The very first thing we have to do, so let's put a big star here. I know that some of yours is not legible, so you may want to rewrite it at the bottom, right below your steps that you need to clarify for yourself. The very first thing we're going to do is factor out the greatest common factor. If And then you have to remember, since our end expression has to be the same, equivalent to the beginning expression, if you factor that greatest common factor out, you have to include that as one of your factors at the end. Alright, so, we don't have to do this for all of them, this is an if necessary. So looking here at this expression, the coefficient of 3, 2, and negative 5, there's not a common factor in the coefficient, and the terms don't all have an x, so we can't factor out an x either. So we don't need to do that on this one. So the next thing we're going to do is we're going to fill in our x, right? Fill in our, they call it a diamond, to fill in this big x. We're going to multiply 3 times negative 5, that's our product. And we're going to use the middle coefficient. That's going to go in the bottom. So if that's plus 2, then that's a positive 2 there. Now we need to fill in our spots, just like we did yesterday. What goes here? What goes on the left and right here, Gregory? Negative 3 and 5. Very good. So negative 3 times positive 5 will give me negative 15. Negative 3 plus 5 will give me positive 2. Alright, so the next thing that we're going to do is just give yourself 2 empty parentheses. And then we're going to write the first term here and here. But this is 3x squared. We're going to write it without the exponent of 2. So we're going to write 3x here and 3x here. And this is nonsensical at first because we know that these, when you multiply together, have to be this first term. But this is not our final answer. This is our work. Alright, so we drop the exponent of 2, put those both in the first spot, and now we take our factors here and fill them in for the second term in each of these parentheses. These are not our factors, so we've done this one, and we've done this one. And we've done this one. Now, this is important because this, when you multiply, it does not equal this. We're going to factor out and cancel any greatest common factors in each binomial. So is there a greatest common factor in this first binomial? What is the greatest common factor there? 3. So we're going to divide that one by 3, not by 3. Now, that's x minus 1. Is there a common factor in these two terms? So we just bring that down. And guess what? That is all. Pretty darn easy. So step 1, factor out the greatest common factor if necessary. Step 2, fill in our x. Step 3, plug in our first term and plug in the factors from our x. And then simplify or pull out a greatest common factor if there's one left. Any questions? Alright, well, let's go ahead and do another example. Is there a greatest common factor to pull out? Alright, so first coefficient times the constant, that goes in our top spot. So we're multiplying that. The middle coefficient goes in the bottom spot. Now we're going to fill in the other parts of our x. 15 and 2, she figured that she's right. 15 times 2 will give you positive 30, and 15 plus 2 will give you positive 17. Every single time, we give ourselves these two parentheses. And we're going to plug in this expression without that exponent of 2 in both spots. We're going to put our 2 factors here in the second spot in each parentheses. Now 6y times 6y is not 6y squared, right? So we're not done. Make sure you're thinking about that, right? Don't forget. Now we're going to look here. Is there a greatest common factor in 6 and 15? There is. answer, let's do a quick check. 2y times 3y is 6y squared. 2y times 1 is 2y. 5 times 3y is 15y. And 5 times 1 is 5. These are like terms, so we simplify. And this is the same as this. So we know that we have factored this expression correctly. Any questions? Y'all caught up with me? Do you need more time? Okay. All right. Is there a greatest common factor in this expression? Yeah, what is it? 4. So let's take the 4 out. So once you take that greatest common factor out, we're not multiplying 4 times negative 16 here. We're going to be multiplying the first and last term of the factor in here. So this is going to be x squared plus 3x minus 4, right? 4x squared plus 12x minus 16. So now, when we're multiplying this 1 times negative 4 here. That's what goes in the top of our x. This middle term is what goes in the bottom. And now we're filling in our factors. So if it's a negative, we know one's going to be positive and one's going to be negative. 4 and negative 1 is correct. 4 times negative 1 is negative 4, and 4 plus negative 1 is 3. So now when we put our next set of parentheses, I would encourage you to go ahead, even though this is not our final answer, bring down your 4 so you don't forget it, because that's what happens a lot. If you have to pull out a greatest common factor, kids forget to include that in their answer, right? So what's going to go in this first spot? So x in both first spots, right? But then yes, plus 4 here. What's going to finish off this other binomial here? Minus 1, right? Is there a greatest common factor in either pair or set of parentheses? There's not. So that's our final answer. Yes. So once we factored it, this was x squared, which means that coefficient is 1, right? Positive 1 times negative 4 is negative 4. Any questions? Right. Is there a greatest common factor here? All right, let's go ahead and pull it out. Then let's go ahead and fill in our x. What's going to go in our x? So in all 4 spots. What goes in the top spot? Nope. Remember, oh yes, my bad. So we're using these new ones, and that is negative 72. And what goes in the bottom? Not 2, but 1, right? 1. So if you multiply them, they should be negative 72. If you add them, they should be 1. Remember, the negative means you have to have 1 positive and 1 negative. So what are we put there? 8 and 9. Which one's positive, which one's negative? 8's negative, right? Negative 8 plus positive 9 gives me a positive 1. So now I'm going to bring down the 2. This is our work. This is not going to be our final answer, but we don't want to forget the 2. What's going to go in this first spot in both parentheses? 12n. So that first term without that exponent is 2. And now what's going to go, the second part here, second term in the first parentheses is going to be minus 8. And this plus 9. And now that is not our final answer. 12 times 12 is not 24n squared, right? Or 12n squared. So now we're going to divide common factor, the 4 here. So now I'm going to go ahead and bring this down because I'm getting to my final answer now. 3n minus 2 times, what's the greatest common factor of the second parentheses? 3. 3n be 3n times 4n, that would be 12n squared, times 2 would give us our first term. And we could multiply it all out and multiply by 2 and see that our expression here is equivalent to what we started with. Any questions on example 4? Alright, let's do this one. Y'all fill in the x. Y'all fill in the x. Come on, Grace, follow along with us right now. Let's do number 5. Marshall, fill in your x in number 5, buddy. I think you draw your x and then fill it in. What's going to go to the top, Gregory? Say it again. Negative 9 is going to go on the top. Nope. So there's not a greatest common factor still out here, right? Sorry? Okay. What's going to go on the top here, patient? What's going to go on the top part of the x here? Good. 4 times negative 20, negative 80. What's going to go in the bottom one? Patient? It's the middle term, baby. Always the middle term. Negative 11. Don't forget the sign. So we're looking for the factors of negative 80. You multiply them, you get negative 80. If you add them, you get negative 11. Anybody got it? So remember, if you get stumped, start listing the factors. And you're looking for a difference of 11 when you add them. So 5 minus 16 would give me negative 11, right? So 5 and negative 16. So now our triangle, or our x is filled in, and we can go ahead and start plugging in to our parentheses. Gregory, what goes in the first spot, buddy? Sorry? I can't hear you. What are you looking at? Look up here right now. You're here now. What goes in the first spot here? Now look at example 1. I'm going to show you. Look at example 1. 3x squared, we put 3x and 3x. Let's look at example 2. 6x squared, we put 6y and 6y. Example 3, 4x squared, well, it's a little bit different. Here, x squared, we put x and x. Example 4, 12n squared, we put 12n and 12n. So for example 5, Gregory, what's going in the first spot? 4, just 4? There you go, 4x. All right, what's going to go, what's going to finish out these groups? Hannah?
Minus 5 and minus 16.
Plus 5, right, a positive 5, yeah, and minus 16. You could do them this way. You could have done minus 16 and plus 5, that doesn't matter, right? But you have to do positive plus 5, you have to do minus 16. So now, there's nothing that we can factor out of that first binomial factor, so we're just going to bring it down. But this one, we can take something out of both terms, right? What can we take out of both terms, Lewis? 4. Good. So, I'm going to check this one real quick. 4x times x, 4x squared. 4x times negative 4, negative 16x, plus 5x, and minus 20. These will simplify to negative 11x. So our check proves to us that we have rewritten this as a set of factors for this expression. Any questions? All right. Is there a greatest common factor we can pull out of number 6? Nope. So what's going to go in the top and what's going to go in the bottom? Negative 9 on top. Very good. 3 times negative 3. What's going to go on the bottom? Yes. So always the middle coefficient. So this is a product. This is a sum. Negative 8 is our middle term, so it's going to be negative 9 times positive 1 will give me my negative 9, and when you add them, you'll get negative 8. What's going to go in these first two spots, Gregory?
3 and 5.
Good. 3 in both spots. What's going to go in these two spots, Alana? The other parts of the parentheses. What's going to go here and what's going to go there? Sorry? I asked you if you wanted to sit in my desk. You go sit in my desk and then I'm going to ask you. Go sit. It's almost like I'm paid to teach you. I'm going to let you do the next one because we want to keep moving. Who can tell me, Deb, can you tell me what to put in these parentheses? Yes, minus 9 and plus 1. Now this is not our final answer because there's a common factor here of 3. So we're going to take 3 out of both of those. Whatever that greatest common factor is, you divide both terms by it, and that would give us 10 minus 3. This one does not have a greatest common factor, so we just bring down that expression, that factor. You need something? You don't have, oh, it's on your desk. You must have. I know there's a bunch of junk on my desk. We can use that later. Okay. Is there a greatest common factor in example 7? All right, let's go ahead and fill in the X. Bailey, can you tell me what is the top and bottom example 7? 40 and negative 22. So what we're going to be the factors that I plug into the left and right? Good. Negative 20 and negative 2 will give me a positive 40. Negative times a negative gives me a positive. And negative 20 plus negative 2 is negative 22. So that's where we started. Mrs. Zimmerman. It's alright. She's not here. You're occupied. Okay. So, Alana, what goes in the first spot? In example 7. In each parentheses, what goes here and here? What am I looking at? Example 7. So look here. It was 3n squared, so we put 3n and 3n here.
So is that it?
5a goes in both those spots. That's right. That first term without that exponent of 2. So what goes in the next spot, Solana? Here and here. So let's get this example. We have negative 9 and 1.
Negative 20 and
negative 2. Negative 20 and negative 2. And the last thing is to look for greatest common factors. There's a greatest common factor of 5 in these two terms, so that's going to be a minus 4. And there's not a greatest common factor there, so we just bring it down. All right, any questions? Last one. If you don't take a greatest common factor out, for one thing, your factors won't be, it won't be in simplest form. So when we factor, we want to factor in simplest form. So we want all our factors to be broken down as much as possible. Not only that, you'll have these big numbers to work with. So there's a 3 that'll come out of all 3 of these terms. So we're going to go ahead and factor that out. 30 j squared minus 27j minus 21. So now remember, I don't use these 2 terms or this little term. I use these 2 terms and this middle term. And I'm looking for the factors of negative 70 that will add up to 90. I mean 9. Negative 9. Thank you. The 14 and 5? 14 and 5. So which is going to be positive and which is going to be negative? Yeah, next 14 is negative, that one's positive. So now we are going to bring our 3 down so we don't forget it. But we know this is probably not our final answer. If there's a coefficient on the first term, this is never going to be our final answer. If there's not a coefficient on that, if it's a coefficient of 1, then this would be our final answer. Alright, so we're going to put in 10j in both spots. Remember that term without the f2. We're going to plug in these as the second terms in each of these parentheses. And now we're going to simplify. We're going to factor out a greatest common factor in each of these to get our final answer. So I'm going to go ahead and write my final answer spots up here. Divide both of these by 2. It's going to give me 5j minus 7. And the common factor here is 5. Divide both of those by 5. 2j plus 1. So that would be your final answer. If you do not include the 3 in that answer, it is wrong. This, when you multiply it together, has to be equivalent to that. That's it. You can scan and submit your notes, and go ahead and start working on your worksheet. Don't forget to put your comment in there about when you're, the date you're at.
Wait, is this only day we have work?
Yeah, we didn't have work on Wednesday.
This is a great thing. What is the fix on recording? What's wrong with that? These apps does it no matter how much they make it out.